Good. Hello, Assalamualaikum. Today I will present about my project, weather monitoring system. Okay, this is our member for this team. My name is Muhammad Ilman Aziz bin Abdul Razak and my teammate Siti Nur Ain binti Cik Salim. Okay, now I will present to you about background a little bit of my project. So our project is weather monitoring system that is a device that provides real-time climate information to farmers, helping them make informed decisions about their agricultural activity. The system can monitor various weather parameters that directly impact farming, such as temperature, humidity, and rainfall. Okay, now we talk about project goals. For this project, we have three goals. The first one, improve agriculture productivity by leveraging real-time weather monitoring system to provide farmers with accurate and timely climatic information. Okay, for the second one, promote sustainable farming practice by integrating weather data to minimize environmental disturbance. Third, empower farmers with reliable and actionable information for effective crop management. So the farmer will know the accurate and will how to manage the farmer. Okay, for our project, we have used a few hardware main for this project. So for the first one is ESP32. As we can know, ESP32 is a low cost and low power microcontroller with integrated Wi-Fi and Bluetooth. So because of this project, we need use ESP to connect to the fabric and to our computer to see the data. So this is our second one for our main hardware. So as we can see, we use BME3280. So the function of BME is measuring temperature, humidity, and also pressure. But for our project, we only use temperature and humidity. Okay, the temperature that it can sense about negative 40 degrees Celsius to 85 degrees Celsius. So over the temperature range of to 65, accuracy is plus minus 1.0. So it's not too accurate. So for the humidity, it can measure relative humidity over a range 0 to 100%, with an accuracy 3% only. Okay, so now is OLED 130C. This is our third main hardware. So we use OLED for the output for our project. On the screen, it will show the temperature in degrees Celsius and also Fahrenheit, and it will show the if the rain detector it will display rain detect or no rain. So as you can see, the characteristic of the OLED is a single chip monochrome OLED that screen only 128 pixel with wide and non-64 pixel depth. So for this OLED, it can reading the BME sensor which are value of the temperature and humidity. So it will display of the output in the next part of the slide is part of the result. Okay, for next is rain sensor. The raindrop sensor is a tool used for sensing rain. It consists of two modules, which is rain board and control module. So it can compare the analog value and convert it into a digital value. Okay, as you can see, we also use LED. It stands for light emitting diode. This is a upload electronic device which works on the principle of electroluminescence. The electroluminescence is the property of the material to convert electrical energy into light energy. As you can see, the object is a compact, save energy, and has a low surface light and high degree of design freedom. So for our last output, which is buzzer, a buzzer is more efficient component to add some features to our project or system. It is very small and compact, which is only 2-pin structure. So the buzzer can be used by simply powering using DC power supply ranging from 4 volt to 60 volt. So the buzzer is normally associated with a switching circuit to turn on or turn off the buzzer at required time and required interval.
Next is process the condition for ring sensor. If not roaring value, let's make roaring value equal to 0, the buzzer will on. The terminal will display buzzer on ring detected. As roaring value equal to 1, the buzzer will off and the terminal will display buzzer off no ring. Next is process for condition for maybe 280 temperature. If temperature is higher than 30 Celsius, LED red will blink in 5 times. If temperature is less than 35 Celsius, LED yellow will blink in 5 times. As temperature is less than 39 Celsius and more than 34 Celsius, LED green will blink in 5 times. Next is flowchart. First, start upload ESP32, import the order directory, device URL, and the terminal will display weather monitoring. BME 280 will measure temperature in Celsius and Fahrenheit and humidity in percentage. The terminal also will display the roaring value, 0 or 1. If temperature is more than 30 Celsius, LED red will blinking. If temperature is less than 25 Celsius, LED yellow will blinking. Else, LED green will blinking in 5 times. If not roaring value equal to 0, if not roaring value, that's me roaring value equal to 0, OLED will display then detected. Buzzer will on and the terminal also display buzzer on then detected. As no rain, the OLED will display no rain and buzzer will off and the terminal display buzzer off no rain. If you press the Ctrl C for encoding, so no loop. If no, it will loop again to BME 280 to measure temperature and humidity again.
So for the next part, it will show result in VS Code. So first of all, it will print weather monitoring, and for the output and input, it will display for the first one raw value 0 and 1. 0 stands for if rain and 1 if not rain. So the second one is temperature, unit in degrees Celsius and also Fahrenheit. It also will show humidity, unit in percentage, and display buzzer on or off if it detects rain. Okay, so the result in favorite platform, which is output, it will show date, real time, rain and no rain, humidity in percentage, and temperature in degrees Celsius. This table is come from our input, which is BME and rain sensor. It will auto detect and automatic will make in a paragraph. So this is our graph. As you can see, the 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 purple one is for rain, the middle one is for temperature, and the blue one is for humidity. So for the next part is design in circuit, which our output OLED and LED and also buzzer. So for the first one, OLED will display weather monitor, which is temperature in unit degrees Celsius and Fahrenheit, and also humidity. So for the rain sensor, it will detect rain or no rain. So for the next one is LED and buzzer. So for the LED red, it will blink if the temperature is same or higher than 30 degrees Celsius. LED yellow, it will blink if the condition is temperature is below or same 25 degrees Celsius. So for the LED green, it will blink if the condition is more than 24 or same and below 29. For the buzzer, it will buzzing if it detect rain and no rain.
Conclusion. In conclusion, this winter monitoring system is not great importance for many sectors, especially agriculture. This potential of reducing risk and improving performance will add component. Communities can use this technology to protect crop, optimize the resource uses, and preempt environmental hazards. Hence, adopting this system not only guarantee agriculture sustenance but also emphasize its vital social significance, affirming its essential role in encourage sustainable practice and ensuring the survival of all. That's all for us. Thank you.